Figure 1 shows a sector OAB of a circle. Now the circle has center O and radius 10. Now this sector has an area of 25 and the angle is theta radians. Cool. They want us to find the value of theta, so this angle, plus the length of the arc, AB. So arc is here, A to B. Now, typically with this kind of question, guys, every time you're dealing with sectors, it's good to write down all the relevant formulas, yeah? So the first one we see straight from the beginning is the area of the sector, yeah? So the area of the sector is like this. It's A, which is area, equals half r squared theta, okay? And the length of the arc is the other one, which is L equals just r theta. Now all you gotta do, guys, is just update these values, yeah? So we know that the area is 25, so A is 25, and the radius r is 10. So this means for the first equation, we're going to have 25 equals half times r squared, so half times 10 squared times theta. Whereas for the second one, it's just simply L equals 10 times theta. Cool. Now going to the first equation here, we can just literally rearrange to find theta. So we got half times 10 squared. 10 squared is 100. Half of that is 50. And then we divide it across, so we have 25 over 50. So we can say theta equals 25 over 50, which is just half. Now therefore, if you substitute half into the second equation, the length of the arc is just 10 times a half, which is 5. And that's it, guys. We got both results. Now let's move on to the next one. Cool. So the equation here, which is 3x squared minus 5x plus 4 equals 0, and it has two roots, yeah? Alpha and beta. So what this means, guys, is that if these were just regular numbers like, I don't know, 2 and 3 or 1 and 4, etc., this means that if you factorize this, you get two solutions. The two solutions they use are roots, okay? Now, without solving this equation, form a quadratic equation with integer coefficients. In other words, keep it all in whole numbers, yeah? Your quadratic equation that has roots of these two quantities. Alright, cool. Now, let's take this step at a time, yeah? So on the first line, it tells us that this quadratic equation has these two roots. So what that means, yeah, and without solving this equation, we can say that if we somehow factorize this, yeah, if we work backwards, you would ask yourself, firstly, what two numbers do we need to multiply to get a 4? Okay, in this case, we need to use alpha and beta. Let's write this here. To get a 4, so to get your constant C, we need alpha times beta, yeah, so alpha beta. However, when you have like a quadratic equation where the value of a, the coefficient of an x squared is not 1, so in this case it's 3, you got to multiply one of these two values by 3. So it'll be 3 times alpha beta, and this is supposed to equal 4. So that's one equation. Now the second one we also need to find is usually the middle part, the beta. And we say, okay, if we got our two roots, if we add up these two roots, it should equal that. But because you got, again, 3 here, you got to multiply them. So we can say, alright, to get, in this case, minus 5 here, it's going to be 3 times your alpha plus beta, your two roots. And it'll give us minus 5. Now, from here, we can say that from both equations, alpha beta, for the first one, if you divide it by 3, equals 4/3. And for the second one, alpha plus beta equals minus 5 over 3. We could solve this, you know, and get individual results. That's cool too. But let's just leave it at this for a second here, because we can solve this quite fast. Now, since we showed you how to do the first one, let's try the second one, guys, yeah? So it's literally the same equation, but the only difference is we need to form a quadratic equation. So let's call this quadratic equation, I'm going to change the letters here, so I'll use capital letters. So capital AX squared plus capital BX plus C equals 0. Now we need to work out what A, B, and C is. And we know part of the solutions. We know that it has these two roots here. And the first one had these two roots. So let's copy the idea, yeah? So using the same method here, let's say, like just how we're able to find 4, let's say to get capital C now. So to get C, we just have to do, again, the first term, so it'll be capital A times your two roots. So our two roots are these two terms, so it'll be alpha plus 1 over 2 beta times beta plus 1 over 2 alpha. And again, this is supposed to give us a solution of C, yeah? Now, all you have to do is just expand the bracket here. So therefore, we're going to have, let's see. Let's have a look. So alpha times beta is alpha beta. Alpha times 1 over 2 alpha. So that's alpha over 2 alpha. So basically, alphas cancel out. You got half. Next one, beta times 1 over 2 beta, that's just 1 over 2. And lastly, 1 over 2 beta times 1 over 2 alpha, that's actually 1 over 4 alpha beta. Cool, that's supposed to equal C. Now the good thing here, guys, yeah, is that you don't actually need to, again, work out these terms individually. We can use the results from the first part. We know alpha beta equals 4/3, yeah? So let's replace this one with 4/3 and that one with 4/3. So now we have A bracket 4/3 plus, well, a half plus a half is 1 whole, plus, so 1 over 4 times that. So 1 over 4 times 4 over 3. And again, that all equals C. Now, what you could do, because there's a calculator test, you could put all of this in your calculator, yeah? And if you do that, you should get a result of 121 over 48, yeah? So take your time, guys. Put this in a calculator, see if you can get that result. Now you got this result, you can say, therefore, you're going to have A times that coefficient, so it'll be 121 over 48A, and that equals C. So we'll leave this one here. So we found a C so far. Now, let's try and find the second term. So just like how we found -5, let's find B. So we could say to get, let me go down a bit, to get B, using the same idea, previously when we found the second middle one, we had to add up the two roots and times against the first term 3. So in this case, we're going to add up these roots and times against A. So it'd be, in this case, big A, and then we're going to add up the two roots. The two roots were alpha plus 1 over 2 beta, plus, and the other second root was beta plus 1 over 2 alpha, and that's supposed to equal B, guys. Now, what we could do, we can just rearrange this order, yeah? Because we know from the solutions that alpha plus beta is -5 over 3, so we can add this up. Alpha plus beta is -5 over 3, so we've got A bracket -5 over 3 plus. Now, for these two terms, what we can do, we can just combine them and make sure they have common denominators, yeah? So one has beta, one has alpha. What we can do, we can times up and down here by alpha, and times up and down here by beta, yeah? If you do that, you're going to have alpha over 2 alpha beta. So we know basically both of them would be over 2 alpha beta, yeah? The first one, this would be alpha, and the second term, this would be beta. Cool. And now all of this, again, is supposed to equal capital B. So guys, one thing to be careful here, try not to mix up your betas and your B's, or if you're using little lowercase letters, try not to mix your little a with your alpha. Now, final part here, guys, yeah? So now we can update the results. So we've got -5 over 3. We know what alpha plus beta is. It's just, again, -5 over 3 in the top line. On the second line is 2 times alpha beta. Alpha beta, we said previously, is 4/3. So this would be 2 times 4 over 3. Cool. And that's going to equal B. Now, again, put all of this in your calculator. I'm not going to lie, guys. This is a lot of steps in it. So put this in your calculator, and what did I get? And I got -55 over 24. Don't worry if the answers are slightly different to the mark scheme, yeah? Because the final result will be the same. I was going through this a couple times. Now, because that's -55 over 24, again, so that means the final solution for this part would be -55 over 24 times A, and that gives us our B. Finally, guys, now we can wrap this up here. So we found our C, we found our B. We're gonna go ahead and update this quadratic equation now with our results. So just quick key reminder, yeah, our C result was here. So C was 121 over 48A, and B was over here. That means our quadratic equation is now ax squared plus, well, not plus, it won't be bx, it'll be minus 55 over 24ax plus, and our C value we said was 121 over 48a. So plus 100 over 21 over 48a equals 0. Cool. Almost done, guys, yeah? So one final step. 2 steps, actually. So because they all have a's, you can just divide a across so that it disappears. And now, in the beginning of the question, this would usually be the end, yeah? But they said, without solving an equation, form a quadratic equation with integer coefficients. So in other words, you got to make sure that your final results are all whole numbers, yeah? Not fractions. Now, to make this into whole numbers, let's just clear the fraction, yeah? So let's times everything by, let's see, 48. Because we know this is like a factor of 48. So times in 48 through, you should get a final answer of 48, oh, that's not 8, 48x squared minus, well, 55 over 24 times 48 is 110. X plus the last one, 121, equals 0. And that's it, guys. We've done it. Alright, cool. Now, in triangle ABC, AB equals 12 and BC equals 9, yeah? And angle BAC equals 42 degrees. Cool. So let's just sketch this out for a second, yeah? So you got A, B, and C. So let's say A, B, C. AB is 12, BC is 9, angle BAC is 42. Alright? Now, A. Find in degrees to the nearest 0.1 degrees each of the two possible sizes of angle ABC. So we're talking about angle ABC. So we're talking about here. Okay. An easy way to find the value x, guys, is to firstly work out the value of the angle next to C, yeah? So let's just call this angle here y for the sake of it. Now, what I would do is that I would use either the sine or the cosine rule, because these are the rules that always work for triangles. Now the trick is, if you're working with 3 lengths, then you're using the cosine rule. If you don't, then you have to use the sine rule. So let's match up what we know, yeah? According to the sine rule, we match up length with angle. So we've got 9 over sine 42. That's one of them. Now we need to find something else. Well, we also have 12 over sine y. Okay, cool. So now all we have to do is pretty much rearrange to make sine y the subject. So another way you could do this is write it upside down. So we're going to have either sine 42 over 9 equals sine y over 12. This is easier because that way we can just multiply 12 across to get sine y. So multiplying 12 across, guys, yes, I'll do it here. We're going to now have 12 times sine 42 over 9, and that equals sine y. So go ahead and put this in your calculator, and oh yeah, make sure your calculator is set to degrees mode, yeah? The reason why is because in question 1, you probably had it set to radian mode. So you have to set it back, otherwise your answers look a bit funny. Now work this out, guys, and then when you get a result, sine inverse that answer, yeah? And that will give us our result for y. And when you do that, you should get a y result of 63.1 degrees to 1 decimal place. Okay? Now, another thing you also need to do is, let's have a look. Yeah, so because they want, two possible sides of angle ABC, we should also have 2 possible sides of angle y, yeah? Because of the sine, sine property, they'll either think that you get an obtuse angle or an acute angle, so they're not really clear. At the moment, we've got an angle less than 90, so this is acute. To get the obtuse version, you just got to take this away from 180. So let's just call this the first angle, yeah? To get the second angle, it's going to be 180 take away 63.1, and this should give us 116.9. So this is our second angle, our obtuse version. Now that we've got y, we can work out x. So let's do this. So therefore, to get x, guys, yeah, it's going to be, well, we know all angles in triangle add up to 180. So we can subtract 42 and one of these pairs. So let's subtract 42 and 63.1 from 180. If you do that, guys, that means the third angle will end up being 74.9. That would be your acute one. Now, if you use the other one, if you subtract the obtuse angle, so you got 42, 180 take away 42, take away 116.9. Your other tiny angle would be 21.1 degrees. And that's it, guys. You got your 2 pairs of angles. Now for the last part, part B, it says find to 2 significant figures the smaller of the 2 possible areas of triangle ABC. So again, to do that, you just got to use an area of a triangle formula. So let's do it. Well, because your triangle isn't a right angle and you haven't got any, you don't know if this is a base or not, we should use the other area triangle formula, which is the half AB sine C rule. Okay, we just need to pick two lengths between an angle. So let's focus on x here. So we're going to basically take this shape. These two will be our A's and B's, and this will be our C. We could say that the formula now is half times 12 times 9 sine and then x. Okay, well, if you want to pick the smaller area, you're going to pick the one that has a small angle. So using 21.1 for x, if you substitute that in, so just replace this with 21.1, you're now going to get an area of, if you do it carefully in your calculator, guys, roughly 19 centimeters squared to 2 significant figures. And that's it, that's really it for number 3. Now, for number 4, it tells us that we got a figure 2 and it shows the graph of y equals x minus 1 over 2x squared. So that's how the curve looks like for values between 0.4 all the way up to 5. So that's just the domain of the graph. Now, the question wants us to express this part of the equation as a single fraction. So let's go ahead and do that. When you want to make anything as a single fraction, you must always have a common denominator. So in this case, we got 2x squared. So the first one should be over 2x squared. And to do that, you just multiply up and down by 2x squared. So it'll look like this. So you're going to have it basically x times 2x squared over 2x squared minus, and then just copy the other one, 1 over 2x squared. And well, x times 2x squared is 2x cubed. So your final answer should be 2x cubed, and then combine it, minus 1, all over the common denominator. So that's it, that's our A done. Now, moving on to the second part of A, it says hence. And now when you see the word hence, it literally means carry on from the previous question in some way. Hence, use the graph to obtain to one significant figure and estimate for the value of the cube root of 0.5. Now, this is not very clear what it's trying to say, but what it really means is that when you got a graph, every time you cross the x-axis, that's the value they want. So actually, this value right here is basically the cube root of 0.5. Also, they say, yeah? So what we're going to do, we're just going to let x equal that value, because that's where it's at. So just say, let x equal the cube root of 0.5. And let's go ahead and make this value, let's go ahead and rearrange this and make some sort of equivalent expression to what we saw up there, yeah? Because remember, this is actually on the curve, so we can kind of link it to that. So just tidying this up, I'm going to cube this side. So we're going to have x cubed equals 0.5. And I'm going to go ahead and try and make it look like 2x cubed, because now you can double it. You're going to have, therefore, 2x cubed equals 1. Now the reason why we're doing this is because you want to make this equation equal to, well, y. So just understand the logic. We have y equals 2x cubed minus 1 over 2x squared. Now if you look at it carefully, if I make this, basically, if I move the 1 across, we're going to have 2x cubed minus 1 equals 0. Now this is telling us literally that this equation is now 0. So all of this is basically 0. So now we have y equals 0. And this matches up perfectly because it actually lines up with the y-axis. So when x equals this quantity, y equals 0. And that's really it. So this is kind of literally what we want. And that's really it, guys. You just kind of need to show that you can kind of prove this using a graph. And now, finally, just to get the answer, just pop the cube root of 0.5 in your calculator, and you should get an answer of 0.8. And that's literally all they want. It says, by drawing a suitable straight line on the grid, so they've actually gave us a hint what straight line we're going to draw, find and estimate the two significant figures for the root of the following equation for the same interval. Now, at first glance, we need to firstly recognize, like, does this look familiar? And if you look back at the earlier question, you can say yes. It kind of looks like, you know, y equals x minus 1 over 2x squared. We just kind of need to show it. So let's go ahead and try and reproduce this bit over here. So we'll try and factorize it in. So what we can do, we can probably move 2x and 1 over 2x squared to the other side. So let's just take our time here, guys. So we're going to have 4 equals 2x minus 1 over 2x squared. And just to be a little cheeky here, guys, we can just, because we just want an x, let's just subtract an x across to the left hand side. So now we got 4 minus x equals x minus 1 over 2x squared. And therefore, we can see that all of that expression equals y. So therefore, the right hand side equals y. So this is essentially y equals 4 minus x. And that is literally our straight line we need to plug in. So let's go ahead and just draw a straight line on this graph now. So we've got y equals 4 minus x. Again, if you're not too confident of drawing straight lines, it always helps to just draw like an xy grid. Now, let's just pick a value, yeah? Let's just say when x is 0, you plug in 0, you got 4 minus 0 is 4. And I'll just say pick another one. Let's just say when x is 4. When x is 4, 4 to get 4 is 0. So these are your corners. So you can say your first pair of corners is 0, 4 occurs here. So you got 0, 4. And conveniently, the second one, when x is 4, y is 0. So this is the other coordinate. So you want to draw a nice straight line. I'm not going to lie, it's going to be hard, so I'm going to draw a dotted line. I know it's going to cut like that. So you can kind of see that the question asked again, just going back to the question, it says find an estimate to two significant figures for the root. When they say the root, it means when does it cross the curve? Well, it crosses around here. So we can see that this is literally crossing around when x is 2. So that's our solution. So x is basically 2. But let's just say 2.0 because I think they said, was it two significant figures? Yep, so 2.0. So if you wrote 2.0, you should get a mark. And that's it. Whew. So integration is definitely one of my favorite, guys. So let's have a look at this. Now, first one. Find the integral of 3 minus x plus 1 over x cubed. Now, before we integrate anything, guys, when you got a fraction, everything needs to be written in terms of x to the power something. So let's go and just rewrite this, yeah? We want to find the integral of 3 minus x plus, so because you got 1 over x cubed, that's the same as x to the negative 3, yeah? Always bring it back up. Now, integrating that, that's quite easy. If you integrate 3, you just stick an x. If you go an x, you add a power, so it'd be x squared, and then you divide it by its power you see, which is 2. And do the same here. Because you got minus 3, add 1 to the power, so it becomes minus 2, so it becomes plus x to the minus 2 over minus 2. And never forget the plus c. And then therefore, guys, tidy up. You should get 3x minus x squared over 2. You got minus sign here, so it'd be minus x to the negative 2 over 2 plus c. And that's it. So that's our first part done. Part 2, hence evaluate the same thing, but now you got limits. So when you have limits, all you literally do is just stick a massive bracket. So for you guys, let's just continue over here. So for this would be a part 2. We say now we put a big square brackets. We copy everything in. So x squared over 2 minus x to the negative 2 over 2. And then just ignore the plus c. And then put the limits of 2 and 1 here. Now all you want to do, guys, just firstly plug in 2 over here. Replace x's with 2 and then replace x's with 1. Then make sure you show it, yeah? So the first case, you got 3 times 2. So it'll be 3 bracket 2 minus 2 squared over 2 minus 2 to the power of negative 2 over 2. And then you minus it by the same thing, but replace x as a 1. So you got 3 times 1 minus 1 power 2 over 2 minus 1 to the power of negative 2 over 2. Just check everything's written correctly. Yep. And that's it. And then you just evaluate that. That's it. Now remember, guys, you've got a calculator. So literally put this all in a calculator all at once, including the brackets. And you should get an answer of 15 over 8 or 1.875. That's it. So either one will work. Now, let's look at part B here. So B says, find the integral of 6 sine 3x. So I'm just going to write it over here neatly. So integral of 6 sine 3x dx. Now, quick rule here. Every time you integrate sine or cos, so let's say sine 5x or cos 5x, integrating 5 sine x will always give you cos 5x, and you divide it by the inside, which is 5. And because you're integrating sine, it becomes a negative. If you integrate cos, you get the same thing but a positive, and it'll be sine 5x over the inside 5. So that's the interchangeability rule, guys. Always remember that. Now let's integrate this one. When you got a 6, you can just ignore that. So just be 6, integrate that one, so it'll be minus 6 cos 3x over 3, and then write plus c. And then tidying this up, guys, you should get, well, 6 over 3 is 2, so minus 2 cos 3x. And then don't forget the plus c. Also, so that part's done. And let me guess, evaluate now between pi over 6 to pi over 9. Okay, let's try it out. So we're going to now put a big bracket, put minus 2 cos 3x. And the limits, as usual, would be pi over 6 to pi over 9. So what this means that your calculator should be set to radian mode, yeah? So please put on radian mode. Now, same thing like we did earlier, just basically replace x with pi over 6, and then replace the x with pi over 9 and just find the difference. So just to put it out there, you should therefore get minus 2 cos, and put a bracket, 3 times pi over 6, close bracket, take away, minus 2 cos, open bracket, 3 times pi over 9. So that's how it should look like in calculator. Do that, guys. And just like last time, guys, don't bother working this out. If you got a calculator, use it, yeah? If you put this all in the calculator, you should literally just get an answer of 1. And that's it. This is your final answer for number 5. Now, it says here that the curve C has equation y equals 2x minus 4 over x minus 3. Now, write down an equation for the asymptote to C, which is parallel to the x and y axes. Okay, cool. Before I even start this out, let's just draw a nice x-y axis graph, yeah? So keep it nice and simple. Just give it a little sketch, yeah? Now, what you want to do, guys, is it's always helpful to try and sketch this graph. Now, the easy way to plot these, and I'll be honest, it's actually quite easy, is to basically look at the numerator and the denominator and just, well, make them equal to 0 and find the root. Let's start at the bottom because that's how reciprocal graphs usually work. So if we make x minus 3 equal to 0, you're going to get x minus 3 equals 0, and therefore x is going to be 3. What this tells us is that when we plot this, we're going to have an asymptote at x equals 3. Now this only applies, we're going to look at this properly, but let's just call this one cos at x equals 3. That's what it's going to be. Likewise at the top, if you make 2x minus 4 equal to 0, which is write out neatly, and you solve it, you're going to get x equals 2. Now even though it says x equals 2, we're not going to write x equals 2 here. So what this means is that it's going to cut the y-axis. The asymptote on the y-axis will be at 2. So what I mean by that, just draw another dotted line here, and then call this line y equals 2. Even though I said x, that's just how it is, guys, yeah? And then all you got to do is just sketch it out nicely like that. So this just helps with, visualizing. Now if you think about it, if you answer the questions, it says write down an equation of the asymptote C which is parallel to the x-axis and the y-axis. Well, the one that's parallel to the x-axis is y equals 2. That's the line. And the equation that's parallel to the y-axis, so here's the y-axis, is x equals 3. And that's really it, guys. That's literally both of these done. Now for the next one, find the coordinates of the point where C crosses the x and y axis. So in other words, you're looking at this point here and this point here. Easy way to do this, guys, well, is to just ask yourself, well, what happens when you cross an axis? If you cross the x-axis, this means y equals 0. If you cross the y-axis, it means x equals 0. So that's it. We just have to solve like that. So we can say, okay, therefore, let's let x equals 0. In other words, we're going to try and solve this part. So when x equals 0, what do we have? We're going to have y equals 0 minus 4, so just minus 4, over 0 minus 3, so minus 3. And that's it. That's basically just 4/3. So we can see that the first coordinate is going to be 0 4/3. So let's just write down nicely here, yeah? And then do the same for the other one, yeah? Now we're going to let y equal 0, so I'm just going to just do it here, around here. So let y equal 0. If you do that, you're just going to have basically the whole equation, 2x minus 4 over x minus 3 equals 0. Clearly, when you times x minus 3 across, you're just left with 2x minus 4 equals 0, and you're going to get a result of, just make that, we've done this earlier, you're going to get a result of 2. So the second pair is basically around 2, 0. So we just say 2, 0. And I was going to say, sketch C showing clearly the asymptotes and the coordinates of the points where C crosses the coordinate axes. Well, we already sketched it, and we've done it. So we know that one of them is going to be 2, 0, so 2, 0, so that's 2 across, 0 up. And the second one's going to be, 4/3. So we just put 4/3 there. And that's it, guys. Let's have a look what we have here. So a particle p moves along the x-axis so that at time t seconds, where time is always positive, the velocity of p given by v meters per second is 5 cos 2t. So that's an expression for speed or velocity. Find the value of t when p first comes to instantaneous rest. So instantaneous rest just means when the speed is 0. So in other words, let v equals 0. That's it, okay? So that's basically means you're not moving anymore. Now to do that, just equate this to 0. So we're going to therefore have 5 cos 2t equals 0. And just solve it. Divide 5 across, you still got cos 2t equals 0. My personal advice is to keep your calculator again in radian modes, yeah? And now cos inverse this and then divide it by 2, you should have a result of t equals pi over 4 in your calculator. And then that's basically roughly 0.785 seconds. So that's it. So it basically goes instantaneous rest in less than a second. That's how quick this particle is. Now for part B, find the magnitude of the maximum acceleration of p. Now first things first, let's get to acceleration. How do you go from velocity to acceleration? Well, all you got to do is differentiate. There's like a certain rule here. When you always start displacement first. Let's call it s. S goes to v and then goes to a. This is the order of the differentiation. So if you had the displacement equation, differentiate to get v. To get to a, differentiate again. So we can say, alright, to get a, differentiate this equation. Focus on the cos 2t. Yeah? So let's ignore the 5. So leave 5 for a second. Cos 2t basically becomes a minus sine 2t. So let's put this in bracket, minus sine 2t. And then you got a 2 inside. So you differentiate that so you get 2 outside. So it'd be times 2. In other words, you're just going to get 5 times 2, which is 10. It's going to end up becoming minus 10 sine 2t. That's really it. Okay? So now we've got this value. It says find the magnitude of the maximum acceleration of the particle. So the maximum possible way. So you want the biggest possible value of this expression you can get here. And to get the maximum possible value, we just have to ask ourselves, what is the maximum value sine 2t can take? Now, if you think about it, guys, it's a sine wave, right? So if it's just moving like here and it's floating between -1 and 1, the maximum possible value of sine 2t would be 1. So in other words, the maximum value would be minus 10 times 1. So we could say that the magnitude of the maximum acceleration, so we do this kind of magnitude sign, is just going to be, and when you do magnitude, it's always positive, it will be 10. 10 meters per second squared. That's all it is, guys. When you get sine or cos and they want to find the magnitude or the maximum value of this, it maxes out 1 for both of them. If it's minimum, it will be -1. So you times by -1. And that's it. Now for the next bit, it says when the time is 0, p is at the point A, where the distance OA is 0.2 meters. When p first comes to instantaneous rest, p is at the point B. Find the distance of OB. So what I'll do here, guys, is firstly, because we're talking about distance, we need to firstly get an expression for distance, or in this case, displacement. We already got v, so how do you go from v now to s? Well, if you went downwards, which is differentiation, to go back up, you integrate. So we're going to go ahead and integrate that equation, yeah? So let's just rewrite everything here. So part C, we know that the velocity was 5 cos 2t, okay? Now to integrate this, we're going to call it S. To integrate 5 cos t, just like how you differentiate, instead of, when you differentiate, cos becomes a minus sign. When you integrate, it becomes plus sign. And as for the 2, when you integrate, it goes underneath. So let's have a look. When you integrate this expression, you're now going to get, let's leave the 5 as it is, 5 sine 2t, and you're going to divide it by 2. And then we just write plus c. Now going back here, what's it telling us? It's saying that when t is 0, the distance is 0.2 meters. So let's go ahead and plug that in. So these are your initial coordinates. So we can say, okay, when t is 0, therefore the expression s, our distance we're going to use for now, is 0.2. Therefore, let's put this in. You're going to have 5 sine, remember just use your calculator for everything, yeah? Over 2 plus c must equal 0.2. Let's work this out. So sine 0 is basically 0. So in other words, all of that is 0. So therefore, c must be 0.2. Okay, that's cool, nice and easy. So now let's go ahead and update this equation. So we now have, okay, so the displacement equation is 5 sine 2t over 2 plus 0.2. Now, back to the question, it tells us earlier that, so we've done this part, the first line, so always break into bits. It says when P first comes to instantaneous rest, so this is actually referring to part A, that's when instantaneous rest. And remember when that happened at t equals pi over 4, so let's make that note there. This is talking about when t equals pi over 4. And then that's how we know B is P is at the point B. It wants us to find the distance of OB. Okay, cool. So all it really wants you to do is just plug in pi over 4 for t. And I think that's really it. So okay, so we say therefore for distance OB, when t equals pi over 4, just plug it in. The distance is now going to be, and then again, just plug it all in and then put in your calculator. 2 times pi over 4 over 2 plus 0.2. And I did this already, guys, and I think you should get roughly 2.7 meters. And that's it. This should cover it all.
So, number 8. The line L has equation y plus 7x equals 15, and the curve C has equation y equals x squared minus 6x plus 9. Before I do anything, I just like to rewrite this one in terms of y equals mx plus c, because it just looks better. So let's just make y the subject. So here you get y equals minus 7x plus 15. So I know this is actually a downward line because it has a downward slope, yeah? Because you got a negative gradient. And this one is a quadratic, so it's a U shape. Use algebra to find the coordinates of the points where L intersects C. Cool, so you're going to have a line and it intersects the curve at 2 points. So let's say probably here and here. Now, to do it, all you literally do is just substitute your equation, your line equation, into your quadratic. Because we made it both equal to y, we can equate them. So therefore, we're going to have minus 7x plus 15 equals x squared minus 6x plus 9. I'm going to go ahead and make everything equal to 0, yeah? So it's going to look like a quadratic set to 0. So adding 7x and minusing 15, we're going to have 0 equals x squared plus 1x. So minus 6 plus 7x is just x. And 9 take away 15 should give us minus 6. Okay, so I think this is actually factorizable. Let's have a look. So you need two numbers to multiply to make 6. That's 3 and 2. And they have a difference of 1. Yes. So factorizing this quadratic, you should get, I believe, x plus 3 and x minus 2 equal to 0. And we know this is true because you need to make a positive 1x. So that'd be like plus 3x, minus 2x gives you a 1x, and 3 times minus 2 gives you minus 6. And therefore, right here, the solutions are always the inverse of these brackets. So if it's x plus 3, the solution x would be minus 3. And the other one, x minus 2 bracket, will become a solution of positive 2. So yeah, that's sorted. But they're saying they want to find the coordinates. So now all we got to do is plug these values back into either the quadratic or the line. Well, I'm going to use the line because it's way easier. So replacing your x values into each of these, into the y equation. So for example, this y, the first one would be y equals minus 7, open bracket, minus 3, plus 15. Putting that into the bracket, you should get an answer of 36. So the first coordinate would be minus 3 and 36. If you plug in 2, you should get 1. So the second coordinate would be 2, 1. And that's it, guys. That's literally part A done. Now, as for part B, looks like it's a bit different. Use algebraic integration, so we're talking about doing proper integration now, like opposite differentiation, to find the exact area of the finite region bounded by L and C. So it's actually quite easy. All you do is set up your integral. So you say area equals integral, and our limits are basically between our x coordinates. So between minus 3 and positive 2. So what we do here, we have the line equation, which is equal to y. So it will be minus 7x plus 15. And then we subtract it against the the other y equation, which is a quadratic. So x squared minus 6x plus 9. 6x plus 9. And then dx, of course, with respect to x. And then tidying this up, we've got the integral of minus 3 to 2. You should get, by tidying up, minus
Plus
x6. So
square.
actually literally the opposite of what we did up there. And that's going to be dx. In fact, you know what? I guess I could have just used this equation up here. Now integrating this carefully, to integrate is not too bad. All you do is raise the power up, so minus x squared becomes minus x cubed over the power itself, which is 3. X becomes x squared over 2. And if you just get a constant, you just stick an x in, so plus 6x. And then you close it and you put your limits of integration here. These are the values you're going to replace x values with. So now all you do is replace all of this with 2, and then you subtract it with all of it minus 3. So doing it, put a 1 bracket, replace the 2, so you get minus 2 cubed plus 6 times 2 minus, and then replace the x's with 3, so minus bracket minus 3 cubed, and then you put this all in your calculator, you should get a result of 125 over 6, which is also the same as 20 wholes and 5 sixes. That's it, guys. This is it. Okay, here we go, question 9. So the fourth term of an arithmetic series is 108 and the 11th term is 80. So let's note this down. So this means that U4 is 108 and U11 is 80. And just remember the general UN formula is always A plus N minus 1 times D, where A is the first term and D is a common difference, yeah? And N is just your position. So just updating the formula above. If we got U4, so that's basically A plus, and then 4 minus 1 is 3. So 3D, and that has to equal 108. Whereas for U11, same thing, it would be A plus 11 minus 1 is 10, so 10D equals 80. So these are our two equations that we're going to have to work with. In fact, we can deal with it right now, because part A tells us to find the common difference D and the first term A. So let's solve this simultaneously. So what we could do, we could subtract the equation, so A plus 10D equals 80 minus the top row. If you subtract them, you're going to get A's that cancel out. 10D take away 3D is 7D, and then 80 take away 108, that should give us minus 28. And then dividing by 7, you get minus 4. So the common difference is 4. And now to get A, well, just plug in minus 4 back into either one of these equations, yeah? So let's just put over here, so part A, you've got D is minus 4, and then if we substitute to the first one, A plus 3 times minus 4 equals 108, and then make A the subject, yeah? So you're going to have, well, A, so 3 times minus 4 is minus 12, equals 108, A equals 120. Cool, so the very first term, U1, or A, is 120. Nice, so that cancels both of these. Now next one, the sum of the first n terms is Sn. Show that Sn equals 2n times 61 minus n. So first things first, we need to write the general formula for Sn, yeah? So the sum of the first n terms looks like this. It's always n over 2, big bracket, 2a plus n minus 1 times d. Now what do we know? It says that the sum of the first n terms series Sn show that we get this result. Now, because we know the value of a and the value d, we can plug them both in. So let's try out. So therefore, Sn equals n over 2. 2 times a is 240 plus n minus 1 times minus 4. Okay. Now what we can do here, just trying to think carefully how we can do this. We can go ahead and expand the bracket. So equals n over 2, 240. If you open it, you're going to get minus 4n plus 4. Okay. We keep on going. N over 2, 240 plus 4 is 244 minus 4n. Now, we can divide it by 2. We can actually expand the bracket and divide by 2. Actually, no, let's see what they want. They wanted 2n. Exactly. So let's go ahead and factorize 4 out of this, yeah? Is 244 going to 4? Yes. If you factorize 4 out, you're going to get 4n over 2. And divided by 4, you get 61. Perfect. Minus n. 4n over 2 is just 2n. bracket 61 minus n. And I think we got it. Did we show it? Yes, we did it. Nice. If you've shown this one, then therefore this means that your A and D were actually correct. That's another way to check if your answers are actually good so far. So all this being correct, meaning part A is correct. Now finally, given that Sn is 1100, find the two possible values of n. That should be fine. So just equate your last equation to 1100. 2n, 61 minus n. Okay, so we're going to get quadratic. So let's expand this and move everything to the right side, yeah? So you can get 0 equals, well, 2n times 61 is 122n, yep, minus 2n squared, and subtract that, 1100. In fact, I want to make 2n squared positive, so let's move back to the right side. So you're going to get 2n squared minus 122n plus 1100 equals 0. Okay, and then divide that by 2, just make it easier looking. N squared minus, I actually just kept it at the beginning, 61n plus 550. You don't have to do this, but it just helps. So, to solve this one, we need to use either the quadratic formula, or you can use the quadratic formula in your calculator, or you can factorize. If you guys are not sure how to do that, I'm just going to use the quadratic formula and get the answer directly, yeah? So the quadratic formula is this. It's going to equal minus b plus minus the square root of b squared minus 4ac all over your 2a. And just recapping the values, a is your first term in front of the n squared, so it'll be 1. Call it the coefficient, so just 1. B would be minus 61, and C would be 550. So plugging all in, you either get n equals 50 or n equals 11. And to be honest, both could be fine because they're both positive values. So is that what they want? Yep, that's it. That's our final result. Now, points A, B, C, and D are such that the vector A to B is given by the vector 5i plus 5j, AC is that, and AD is this. Find D to C as a simplified expression in terms of I and J. So going from D to C, so let's firstly understand how we draw this. It helps a lot to draw vectors. So it's telling us from point A to point C, we know we travel with a vector length of minus 2 plus 15. So what I usually like to write, I like to write as a column. I put the I term on top and the J term below, so it'll be minus 2 and 15. Whereas if it went from A to D, so let's say D was here instead. This would be a vector length of minus 7 and 10. Now they want to go from which way? D to C. So I'm going to add a different color pen, it helps that way. D to C. So to get from D to C, you got to follow the known routes. You can go back from D to A and then add A to C. So it's going to equal over here minus 710 plus minus 215. And that's going to give us, so that'll be plus, that'll be 7, take away 2, which is 5. This will be minus 10, add 15, which is 5. So that's our vector. 5, 5. That's the answer to part A. So we write over here in terms of I and J. So for part I, it's going to be 5i plus 5j. Cool. Next part. Hence show that ABCD is a parallelogram. To show something is a parallelogram, then we need to somehow show that there's two parallel lines, yeah? So there's a pair of parallel lines. Let's try and see if we can find them. So we got CD, which is 5, 5. Oh yeah, we got AB, which is 5, 5 too. So if we went from A to B, so if this is going that way, that means we can add like a B vector here. And just say, this is obviously the same parallel line, 5, 5, going to B. And I can just connect this to dotted line C. And voila guys, we've got a parallelogram. So to show something's a parallelogram, you need two pairs of matching vectors, 5i plus 5j. We can say therefore, for part 2, since A to B equals D to C, which is 5, 5, we have a parallelogram. So part B, find the unit vector parallel to B to D as a simplified expression in terms of I and J. Okay, so we know the first part. This first part is actually not too bad. Let's firstly calculate BD and understand how to do that, yeah? So part B, to get from B to D, we just follow the routes, starting from B that gets to D. Well, if we look at B, we can go from B to A, and then A to D. So this equals B to A plus A to D. And that's going to be, well, it's going to be, because you're going through the arrow, it will be the negative version, so it will be minus 5, plus A to D, which is minus 7, 10. And then adding this up, you should get a minus 12 on the top and 5 at the bottom. Okay, cool. So now we have a vector. To get a unit vector is so easy, believe it or not. All you do is literally use Pythagoras on this one. So you square both of them and square root it. So we say, you know, let's call this one u. U equal 12 squared plus 5 squared square rooted, yeah? Put this in a calculator. This is actually Pythagoras value. You should get 13. Okay? And now, we say that the final answer, the unit vector of BD is going to be plus minus 1 over 13 of your vector, minus 12 and 5. Or if you want to keep an IJ form, you can say equals plus minus 1 over 13 of, and you put in bracket, minus 12i plus 5j. Either way, so both answers are valid. Okay, so now for the next part, it says the point E lies on BD such that BE to E to D, the ratio is 3 to 10. So what I did, I drew a dotted line from B to D, so that's our vector arrow. And it's saying that it's closer to the first 3 parts here, whereas the rest of the 10 parts there. So it's probably somewhere here. This could be like roughly where it is. You know, it's pretty close to B, but far away from D. So they want us to find AE as a simplified expression. Okay, there's a really nice trick. All this is telling us here, if there's a total of 3 plus 10, 13 parts, that means the line B to the new one, B to E, it's just basically, you know, 3 over 13 of B to D. That's all it is, yeah? That's how you calculate B to E. So to get to AE, it will just be, let's write down here. Let's solve it down here. We can say A to E is just literally following the vector length. We can travel AB first and then add up this new BE, isn't it? It'll just be A to B plus B to E. That's how you go from A to E. And that should be okay. So let's calculate. So A to B was just 5, 5 plus 3/13 of, that's it. And now we just solve this one. So adding it all up, for the first one, it'll be 5 plus 3/13 of minus 12. So I'm going to do like a massive one. This will give us 29 over 13. For the bottom vector, and that should give us 80 over 13. And that's it. This is your actual final answer. Cool. In terms of I and J, so it's always I and J, and so that could be rewritten as 29 over 13 i's plus 80 over 13j. Now looking at the last one, part D, it says the point F is such that DCF and AEF are both straight lines. Whew, this is a 6 mark, that's going to be a while. DCF and AEF are both straight lines. So let's understand that. DCF, so it's going to be an extension, DCF, and then AEF. So, okay, well, so it'll be kind of like that. Let's make it a bit high, so it's kind of like it, yeah. So they're going to probably intersect at that point. This is the visual understanding of that. So I put F up here. Are both straight lines. Okay. So the best way to solve these kind of problems when you go like ratio vectors is to basically treat the line like D to F and A to F as an extension of A to E and D to C, yeah? So what I'm trying to say here, we could say, for instance, let A to F basically be some scale factor, let's call it mu, of A to E, yeah? So that's what it's saying. So what it's trying to say is, we know what AT is. If we multiply by this mu, by some scale factor, we should get the length A to F. Likewise, we could say D to F equals another one, let's say lambda, of D to C. And then we pick another one. We have to basically say, okay, we got 2 different equations, but we also need a third one, yeah? One that kind of links to both. So what we can say, another way to get to A to F is to go through A to D, or even A to C, and go across. I'm going to go from A to D because we've referenced A to F, isn't it? So our other equation could be AF, basically could be you traveling to A to D first, and then we're going to add, where is it, D to F, right? D to F. So you can see this is kind of where we're going. And we know what D to F is. We basically equate it to, we said it was lambda dc. So here is our other equation here. So the two equations we're really going to use, actually in fact, this is perfect, is the first one here and the second one here. And that's it. We're going to literally equate them together and it should solve the problem. So I'm going to put this right down below. So part D. Okay, so let's begin, guys. Yeah, we're going to now equate these two sides. So we're going to have on the left hand side, so let's let them both equal. So we're going to have mu and AE. So I'll keep on column form because it's easier to work out with. And it's going to equal the right hand side. The right hand side is AD plus that. AD, so minus 7 and 10 plus lambda. Okay. Perfect. Now we just expand and multiply and equate. So we're going to have basically two simultaneous equations. The first equation, on the, if we look at the I column in the top row, it will be mu times 29/13 equal to minus 7 plus 5 lambda. And the second equation that you can see is going to be 80/13 of mu equals 10 plus 5 lambda. Nice. And now thankfully, because we've got 5 lambdas, we can subtract these two equations. Okay, so I'm going to do bottom take away top. So if we start on the right hand side, 5 lambda take away 5 lambda is nothing. 10 take away minus 7 is actually plus 17. And then 80/13 take away 29/13, I'm just writing on my calculator, should give us 51/13. And this is equal to mu. And then therefore, making mu the subject, we're just going to do 17 divided by 51/13, and mu should be 13/3. That's basically what the value of mu is. And then we can work out lambda too. So it's good to just work out everything. So I'm going to just use, I don't know, the first equation. Yeah, so let's use the first equation. So we can make it over here. So we can use the first equation. So we're going to have 29/13 times our lambda value equals minus 7 plus 5 lambda. And making lambda the subject, we should get, let's see, lambda equals all of that, 29/13 times 13/3, plus 7, all of that over 5, yeah, so that's kind of a big one. So lambda should get you 10/3, so that's our answer. So we said now that D to F is basically 10/3 of D to C. And so with this vector, all is saying that if you're going from the ratio of D to F to D to C, and I'm just going to add C to F because that's what I actually want. D to F, so for every 1 unit of DC, you get 10/3 of DF. And then to get CF was just, I think, the difference between the lines. CF is just basically DF take away DC. So subtracting your 10/3 and 1 whole, you should get 7/3. And that's what they want. And just double checking the ratio they actually want. They want the ratio of DC to C to F. So yeah, your final answer would be these two components. You say therefore DC to CF is just 1 to 7/3. And yeah, we got it. That's how you do it. If you guys got any questions on this vector problem, and I admit this vector was quite tough, just let me know in the comment section below. I'll be able to help you guys. Other than that, I'll see you guys next time.